In that video, I would like to just to explain the quantum field behavior and in the vacuum is field of the quantum fields, and you are watching the Spatium. The quantum field has the quantum fluctuations, and these fluctuations are, if you see the visualize these fluctuations are like the balls, the popping out from the vacuum and going back to the vacuum, the disappearing back to the vacuum. And because these fluctuations balls are having the vacuum energy, and they are popping out and they are disappearing back to the vacuum. So when they pop out from the vacuum, they produce the pressure outside. Is they expand and they just disappear back to the vacuum. So that pressure is exerted outside over the surface of that, the popping out ball of the fluctuations which is coming out from the vacuum. So if there are many balls and there are virtual fluctuation balls, we say the virtual particles of the vacuum. So they are producing the pressure to each other, and just assume that this pressure is same everywhere, and it is a scalar field. This media is scalar, and all the fluctuations, the pressure is same everywhere. And if you insert a media, suppose assume that we are inserting the atom or a molecule inside the vacuum, so the pressure produced by the particle, the atom, into the vacuum fluctuation balls will be different than the fluctuation balls, and the fluctuation between two atoms will be slightly different than the outside of the gap of two atoms. If there is a gap between two atoms and they are in a certain distance, assume just in the Fermi scales, or just is a size of atom, if they are in this range, the oscillations of fluctuations will be slightly producing the less than the outside fluctuations, and the outside fluctuation pressure will be more than the inside. So that's it, the two particles get a closer and closer as they are more critically closer to each other. If they are away from the critical distance, like the distance which is more than the fluctuation range of the quantum fluctuation balls, so then the field inside and outside will be same, and there will be no attraction. And these two particles do not experience any force of attraction in the quantum fluctuation field. So if these two particles or two atoms are not excited, or they are not ionized, or they are not polarized, if they are polarized, so the surface energy of these particles, their electromagnetic field will be quantized, and that interact with the vacuum, and it makes changes. It produces effect to the Casmir Effect, which we have described, that that phenomena, the exertions of the force on the two particles inside vacuum, each effect of the fluctuations difference at each point between the two atoms and outside the atoms gap, which is called the Casmir Effect. And the Casmir, while he was conducting an experiment, he was actually the measuring the Vander Waal forces of ionized particles, and he just observed that experience, that effect in the 1948. A Dutch physicist in the 1948, the Hendrik Casimir, he was testing the polarized molecules. He was just trying to calculate the forces, Vander Waal forces of these polarized molecules. But what he found in his experiment, he found that the in the vacuum, when there were no particles, and he just inserted two plates at a distance just few nanometers, it just 10 to 100 nanometers. It is slightly close to each other, and he kept these plates inside the vacuum, and he found that often sometimes the plates were getting closer and closer. They were set close to each other. So he found that he performed that experiment many times, and he found that to be the true, that every time he performed that experiment, the plate were separated at a distance of nanometers, few nanometers, 10 to 100 nanometers, and that he found that they were getting closer and closer because of quantum fluctuations. Pressure outside and inside was different. Inside was less, so the pressure outside was more, and the energy fluctuations was more outside. There, these energy are pushing two plates inside and making them close. The strength of the quantum fluctuation balls are popping out and producing the pressure on the plate over two particles that rapidly falls down. If two particles or two plates are separating away from each other, their distance is increasing, and two particles are moving far away. The strength of pushing them closer will decrease, that fall down, and the measurement, that distance, if the distance is nearly just 10 nanometer or 1 Fermi, less than nearly just less than 100 nanometer. So typically the pressure produced is nearly just 1 atmospheric pressure. Listen that the Casmir effect produced the equivalent pressure equal to the 1 atmospheric pressure at that distance, at 10 to 100 nanometer. This pressure is really amazing. The fluctuation balls of quantum field are producing the pressure. Isn't that the interaction is originated from the fluctuations, and the particles are interacting because of fluctuations, and their own electromagnetic and the strong fields, everything's are connected. The paper published in 2005 by the Robert Jaffe at MIT, the Casmir, according to their papers, the Casmir effect can be formulated and the Casmir force can be computed without the zero-point energy. And they found that the force is the relativistic. The Casmir force of the quantum fluctuation is relativistic. The quantum force between the charges and the currents, the Casimir force between parallel plates, vanish as that the fine structure constant goes to zero, and which appears to be the independent of that structure constant. The Casimir force is simply the relativistic Vander Waal force between the metal plates, and the paper published in the 1978 The Casimir and the Polder's paper they used to derive the Casimir Polder force equations, and they define that the description in the terms of Vander Waal forces is only the correct description from the fundamental macroscopic perspectives, while the other descriptions of Casimir force are merely the effective macroscopic descriptions. So there are the many examples and there are many explanations of to describe the Van der Waals forces in the terms of Casmir Effect and the Casmir Effect that which is happening in the vacuum.